What's going on, guys? In this video we are going to see how to find out the Laplace transform of derivatives. Here we have Laplace transform of first derivative of a function. Now let's see how to find out this one. Now usually you know that when we have a Laplace transform, the equation we use is 0 to infinity. Integral go from 0 to infinity e power negative st, and if it's f of t we put the function right here, but if it's f prime of t we put the f prime of t here, dt. Now for this one we have to do the integration by parts. Here let's pick this one as u and this one as dv, and if this is u then dju is going to be equivalent to negative s e power negative st dt, and if this is dv then v is going to be equivalent to f of t. Okay, now we have this one, and you know that when we have integration of u dv, the integration will be uv minus integration of v dju. Okay, we have u dju dv v, so we can arrange this one in this pattern. If you arrange this one in this pattern, this is going to be Laplace transform of f prime of t is going to be equivalent to e power negative st, because u times v, u is e power negative st and f of t. So e power negative st f of t going from 0 to infinity and minus integration of v du. V is f of t, du is negative s e power negative st. Since okay, let's put all of them, negative s e power negative st and f of t dt, f of t dt, and here we can combine these two negatives, this become plus, so this will turn into f of t, and e power negative st mean that's in the denominator e power st, and going from 0 to infinity, and here it's going to be plus, and we are integrating this one with respect to t, so s is going to be treated as a constant, so we can move this one to the front, and integration e power negative st f of t dt. Okay, now f of t over infinity, because we are substituting infinity for t values, so this is going to be infinity e power infinity e power infinity in the denominator, and we know that whenever we have exponential infinity, that grows faster than anything, so this is going to be much larger than the f of t, so this is going to be 0. So let's start this. Okay, for infinity it's going to be 0, then minus, if we substitute 0, this is going to be f of 0 over e power s times 0, that's going to be e power 0, then plus s times, if we integrate this one, like here you can see this one is Laplace transform of f of t because you can see, like, if it's f prime of t we will have this one, but if it's f of t we will have, like, if we have f of t right here is e power negative st f of t dt, that's what we have right here. So we can, instead of this one, we can just write it as Laplace transform of f of t, and then here we have e power 0 is just 1, so we will have just negative f of 0, and plus s, this whole thing is equivalent to f of s, we call this one f of s, so this can be written as s f of s. Okay, so finally we can, if we rearrange this one and write it in a better way, s f of s minus f of 0, this is the Laplace transform of f prime of t. So this is for first derivative. Now let's see what's going to happen if we have second derivative and third derivative. Let's look at the pattern. Let's get rid of this one, and let me divide this one into two things. Okay, let's divide like this. Now we are going to see the patterns. So if it's first derivative, we have this one. If it's second derivative, let's say we have a Laplace transform of f double prime of t. If you have this one, what's going to happen is we will have s square s f of s. Okay, based on the order we will have s square. First order we have s, so second order we have s square f of s minus this f of 0 multiplied by s, so s f of 0, and since this is second derivative, we will have a first derivative at the end, like we will have f prime of 0. So you can see the pattern. Like let's look at some other, like third derivative, fourth derivative and everything, so we can see the pattern clearly. So let's see what happens if we have third derivative, L f triple prime of t. If we have this one, this is gonna be what, s cube of f of s minus this this is, since we have third order, this is going to be s square right here, s square f of 0, and since we have third derivative here, we will have to multiply this one by s f prime of 0, and also we will have f double prime of 0. So you can see the pattern right here. And let's look at the fourth derivative. Let's write it with a different color. Okay, let's say we have fourth derivative. We have seen second, third. Now let's look at some other one, sixth derivative. So let's say we have f of sixth derivative t. If it's sixth derivative, you can see if it's third derivative, this is 3. So sixth derivative is going to be 6, s6 f of s, and we will have one less power multiplied by 0, f of 0. So if it's 6, we are going to have 5 right here, s5 f of 0, and here one more less power multiplied by f prime of t. Okay, so for this one, this is going to be s4 multiplied by f prime of 0. Then at the end, okay, we have s prime of 0, but we have to take all the derivative. Like if it's third derivative, we have second derivative, first derivative, but if it's sixth derivative, we had to have fourth derivative, fifth derivative. Like it has to like go like fourth derivative, fifth derivative, fourth derivative, third derivative, second derivative, and first derivative. Here we have only first derivative, so we have to take care of all the other derivative. So first derivative here, second derivative, we have to put s cube. The power is going to decrease each time, f double prime of 0, and then for third derivative, we are going to have f triple prime of 0. Then for the fourth derivative, we are going to have one less s. That's going to be s f power f fourth derivative 0, and for the fifth, we won't have any s. So 5 0, and that's it. That's how we do it. Like you can see, if it's 6, it goes from 1 to 5, and if it's third, it goes from 1 to 2. It's like that. So now you can see the pattern. That's how we do the Laplace transform of a derivative function. This is for higher order derivative, this is for first order. And that's it. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn differential equations, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.